Hello again, Year 11. We are going to be starting a new topic today. You might recall me saying that the last topic would be quite short on rates of change, and this is quite a short topic as well, looking at the area under a graph. In some ways, these two topics could be linked together. A lot of mathematicians would argue that these two topics are connected, finding the gradients of lines and finding the gradients of curves and finding the area under graphs. If anyone goes on to study A-level, you will find that this is linked together and it's called the topic of calculus. Anyway, we're going to start today by looking at something that we've already done some work on, which is velocity time graphs and working out the area under some simple velocity time graphs. Hopefully one or two of you might recall that the area under a velocity time graph represents the distance or displacement that something has travelled. Now, since we are going to be finding the areas of different shapes today, I am going to be expecting you to be proficient in this already. The shapes that you'll probably see are rectangles, triangles, and the slightly more complicated trapezium. But these are all formulas that you should be familiar with and all things that you've found the area of before in Year 7 and Year 8. So again, just a reminder about a velocity time graph. We saw in the topic of rates of change that the gradient is the acceleration, but under the graph, beneath the line, represents the distance or the displacement travelled. Now, the reason why I've put the word displacement in brackets is all to do with the fact that we've called this a velocity time graph and not a speed time graph. Velocity is a vector quantity, and displacement is the vector quantity that is equivalent to distance. So I might interchange between the words of distance and displacement, but technically the word that we should use is displacement and not distance. So a quick reminder why it does represent the area. Well, first of all, we know from our work on speed, distance and time that we have the wonderful distance, speed, time triangle. And this says that distance is speed times time. Or in the case that we're going to be looking at today, we have interchanged speed with velocity, and we've interchanged distance with the word displacement. Now, if I took a really simple linear graph showing constant velocity of something travelling 5 meters per second, well, for every second it travels, it would travel another 5 meters. So after 2 seconds, it has travelled 2 times 5, which is 10, which in essence is the area of that shape. Again, just using a little bit of dimensional analysis, and again, this is beyond kind of some of the work that we do at GCSE. If you take something that is measured in meters per second and then multiply it by something that is in seconds, the divide by seconds and the times by seconds cancel each other out, and you'd be left with the units meters. So again, just another quick argument as to why under the graph the area represents the distance or displacement travelled. So let's look at some examples, the type of questions that you're going to do today. And example 1 is very typical of what I am asking you to do. So it says work out the distance travelled in the first 10 seconds for this velocity time graph. Now you can see I've got a section with constant acceleration here, and then I've got some constant velocity. So I've got 2 sections that I will need to work out the area of. One of those sections is a triangle. I'll call that A. The other section is a rectangle. And like I said, the 3 most likely shapes that you will see are triangles, rectangles, and trapeziums. So let's work out the area of A. Well, we can see it is a triangle with base 7 and height 6. So I need to do 7 times 6. But of course, because it's a triangle, I need to remember to divide that by 2. So 7 times 6 is 42, and divided by 2 is 21. So section A represents a displacement or distance of 21 meters. Let's work out area of B. That's nice and straightforward as a rectangle. It is 6 times 3. And that is 18. So the distance travelled altogether is 39 meters. My second example, I thought it would be quite nice to look at a question where we have to finish off the velocity time graph. So, example 2, an object moves as shown for the first 5 seconds. It then decelerates at 2 meters per second until it stops. Complete the velocity time graph and work out the distance travelled. So, you can see it's travelling with constant acceleration in these 2 sections here. And then after 5 seconds, it says it decelerates. Now remember, the gradient of the line represents the acceleration, and if something is decelerating, we know it is a negative gradient. 2 meters per second per second. So that means the velocity will reduce by 2 meters per second every second. So if we are finishing that graph off, and you will use a ruler, we need to draw that straight line in place. So that is the first bit of this question finished. It then says work out the distance travelled. So we have 3 sections to this graph, 3 shapes. And these shapes are a little bit more challenging because A and B are both trapeziums and C is a triangle. Now remember, the formula for the area of a trapezium is you add the 2 parallel sides together, you halve it, and then you multiply by the height. The only thing being is our trapeziums are kind of sidewards. The parallel sides are going to be these sides here that run vertically. Okay, so you just have to be a little bit careful that we're picking out the right numbers. So let me go through A and B for you. So if I look at trapezium A, the 2 parallel sides have length 2 and 5. So I'm going to be doing a half of 2 plus 5. And then I'm going to be multiplying it, while the vertical height is actually this horizontal distance. So that is 3. I think I can just about do this one without a calculator, because 2 plus 5 is 7. Half of that is 3.5. And that times 3 is 10.5. Let's look at trapezium B. So trapezium B, its 2 parallel sides are 5 and 6. So I'll do 5 add 6. I will have to halve that. And then I'm going to be multiplying by that distance there, which is 2. Now this is quite nice actually, because the half and the times by 2 cancel each other out. So I just end up with the answer to 5 add 6, which is 11. And then in C, I have a triangle. Its base is 3, its height is 6. So I need to do 3 times 6 divided by 2. Well, 3 times 6 is 18, divided by 2 is 9. So the total distance or displacement is all of that added together, while 9 add 11 is 20. So this is going to be 30.5 meters. So there are some questions for you to try that are quite similar to the first example. Somewhere they need to be broken up into 2 sections and the area is calculated. some that are 3 sections, and then I think the final question has 4 sections for you to try. So do show some clear working out, set them out exactly as I've done in this video, and remember to use the last few minutes to jump back onto my PowerPoint and check your answers. Of course, if there's any problems, you may contact me in the Ask the Teacher channel.